Hi. In today's lesson, we're going to talk about systems of equations, word problems. So essentially, you'll be given a word problem. You're going to set up a system to solve the word problem and use that system to get your answer. It's really that simple. So each of these problems will lend itself to two equations. So the steps. For each problem, you need to define the variables in words. For example, if you use the variables x and y, you have to say, what does x represent? What does y represent? Write your system, and then you're going to use substitution or elimination to solve that system. So let's look at the first problem. So we've got number problems. So these two problems that we're going to deal with use just regular numbers. So it says last season, 2 running backs on the Steelers football team rushed, should say for a combined total of 1,550 yards. One rushed 4 times as many yards as the other. How many yards were rushed by each player? So we've got 2 players, right? And it didn't say player A or B or anything like that, but we'll just say, let's use our variables x and y. So x is going to be yards rushed by first player. And then we can let y be the yards rushed by the second player. And the reason we're writing this out, telling what x and y represent, is because sometimes the equation or the problem could have said, instead of how much was rushed by each player, it could have said how much was rushed by player 1 or by player 2. So you need to know what each of your variables is representing in order to effectively answer that. Okay. So it says that both players rushed for a total of 1,550 yards. So we can say x plus y is 1,550. That's one equation. The second sentence says one rushed 4 times as many yards as the other. And it doesn't say which player rushed 4 times the other, so it doesn't matter. So one of them rushed 4 times what the other one did. So I can say x is equal to 4 times y, or I could have said y is equal to 4 times x. Either one would have worked. A lot of times you'll see the system written like this, the 2 equations one on top of the other with that little bracket. All right, so now we solve the system. You can solve your systems using substitution or elimination. You could do graphing also, but most of these we're just going to do substitution or elimination. In this particular problem, I would use substitution. The reason I would use substitution is because the second equation has been solved for x. It's in x equals form. I would only use elimination if both equations were in standard form. Okay, so this one, like we said, we're going to use elimination. So I'm going to rewrite the second equation, but instead of x, I'm going to rewrite, the first equation. But I'm going to replace the x with a 4y. So I'm going to write 4y plus y equals 1550. And so I'm going to just kind of do a little highlighting here. This x right here got replaced with this 4y. Okay, so when I solve this, 5y equals 1,550. So when I've got my calculator, so 1,550 divided by 5 is 310. So it means one of the players rushed 310 yards. Now let's find how many yards the first player rushed. So now I need to find x. Well, x is equal to 4 times y. So x would be equal to 4 times 310. So that's 1,240 yards. So that's how many yards each player rushed. So let's see if we answered the question. How many yards were rushed by each player? Boom, we've got it. All right, let's look underneath here. It says the setup. The setup determines the method that we use to choose, the method we will choose to solve the system. Since in this one it says the y variable was isolated, we actually isolated the x variable. The easiest method to use here was substitution, but it doesn't matter. We could have used elimination to solve this system, but we would have had to rewrite the equation x equals 4y. We would have had to rewrite it in standard form. Okay, so what I want you to do now is I want you to try this second one on your own. So read through the problem, come up, say, tell what each variable is going to represent, and then write your system and solve your system. Okay, so pause the video and do this problem now. Okay guys, so here's my system for this particular problem, and I found that there are 659 pages in part 1, 723 pages in part 2. So you're going to want to pause the video and make any corrections that you need to. Go ahead and do that now. Great. All right, let's go to the next page. So now we're talking about mixture problems. Let me slide this over. All right, it says, let's look at the first one. Dennis mowed his next door neighbor's lawn for a handful of dimes and nickels, 80 coins in all. Upon completing the job, he counted out the coins and it came to $6.60. How many of each coin did he earn? So we know he has dimes and nickels. Now, you don't always have to use X and Y as your variable. So I'm going to use a D for dime and an N for nickel. So D equals the number of dimes, and N will be the number of nickels. Okay, now let's come up with the system. So that's two equations. So first, it says he had 80 coins in all. So dimes plus nickels has to be 80. So D plus N is going to add up to 80. The number of dimes plus the number of nickels will be 80. The next thing I see, he has a total of $6.60. Well, a dime is worth 10 cents. So if I do 10 cents, remember that's 0.10, times the number of dimes, that would give me the total amount of money he has just for dimes. Plus, nickels are worth 5 cents. So 5 cents is 0.05. If I do 0.05 times the number of nickels, that's the total amount of money we have just in nickels. The total amount of money in dimes, which is here, plus the total amount of money in nickels, which is the second part that I've underlined, gives us the total amount of money that he has, which I think it was, $6.60. So there's my system. Now we'll solve this system. Now for this particular system, I would solve this system using elimination because both of these equations are written in that standard form. So to solve this one, I've got to multiply one of the equations by something. So do you want the D's to cancel or do you want the N's to cancel? That's your choice here. Actually, you know what? I don't think I'm going to do this one using elimination, and I'm going to tell you why. Instead of using elimination, and the reason I'm not going to use elimination is because I've got decimals here, and who wants to deal with decimals? Plus, the coefficient of D and N here are both 1, so actually it would be very quick to solve for D or N and then just use substitution. So I take it back. Let's do substitution. So if I solve this one, let's solve it for N. N is going to be equal to 80 minus D. Now I'll substitute it in to the second equation. So that's going to be 0.10D plus 0.05. Well, N is 80 minus D. So times 80 minus D equals 6.60. Again, that 80 minus D was in place of N right here. Okay, so let's simplify. 0.05 times 80 is 4, and then that would be minus 0.05D equals 6.60. Now we'll combine our like terms. I have 0.10d minus 0.05d. So that should be 0.05d plus 4 equals 6.60. Subtract 4 on each side. So 0.05d equals 2.60. And then I'm going to do 2.60 divided by 0.05, and I get 52. Okay, so that means there were 52 dimes. And then for n, we know that n is equal to 80 minus d. So if d is 52, n is equal to 80 minus 52, which is 28. So again, how many of each coin did he earn? So Dennis had 52 dimes and 28 nickels. So let's write a sentence over here. 52 dimes and 28 nickels. Okay. All right. Now I want you to try the next two problems. Okay. So pause the video and try those now. Welcome back. All right, so check over the answer or the solution to the coffee and donuts problem. So go ahead and pause the video. I'll zoom in a little bit. Make the necessary corrections. Great. And then here is the one about the different types of solutions for the chemistry teacher. So pause the video and make the necessary corrections. Okay, I do want to point out one thing. Some of you may have just left this one as 0.42, but remember it's a 42% solution of 10 liters. So you need to multiply 42% by 10 here in order to get the correct equation and get the correct solution. All right, let's go to the next page. These are all different types of geometry problems. So you do need to remember things about complementary and supplementary angles in order to do these effectively. And I see a typo. This should be it says two angels. It should say angles. Angles. Okay, two angles are supplementary. The larger angle is 48 degrees more than 10 times the smaller angle. Find the measure of each angle. So we've got two angles. We'll call them x and y. So x can be the smaller angle, which means y would have to be the larger one. Okay, so you need to know what it means to be supplementary. Remember that supplementary angles are angles that add up to 180 degrees, or they form that straight line. So if they're supplementary, that means that x plus y equals 180. So that's your very first equation. The second sentence says the larger angle is 48 degrees more than 10 times the smaller one. So my larger angle is y, and it's 48 degrees more than 10 times the smaller one, which is x. So here's my system. X plus y equals 180, and y equals 48 plus 10x. Again, I would solve this system using substitution. The second equation's already solved, has already been solved for y here. So when I do that, I'm going to write x plus, and instead of y, I'm going to write what y equals. So that's going to be 48 plus 10x equals 180. And just to kind of give you an idea, that 48 plus 10x is being substituted in place of y there. All right, now we'll solve. So that would be 11x plus 48 equals 180. I'm going to subtract 48 on both sides. So I'm going to do 180 minus 48, and I get 132. And then 132 divided by 11 is, I threw my pen. 132 divided by 11 is 12. So the smaller angle is 12 degrees. That's not a 0, that's a degree sign. So let's find y. Y is going to be equal to 48 plus 10x. So that'd be 48 plus 10 times 12. Well, 10 times 12 is 120. And then 48 plus 120 is 168. So the smaller angle is the larger angle is 168 degrees. And it does say to find the measurement of each angle. So one angle was 12 and the other is 168 degrees. Okay, so I want you to do these last two problems. And I will tell you the second one where it says that the angles are complementary. So supplementary angles add up to 180. Complementary angles add up to 90 degrees. Okay, so pause the video now and complete those two problems. Okay guys, welcome back. So you want to check over your answers to these two problems. I'll zoom in. Here's the complementary angles problem. And here's the one about the rectangular garden. Remember that perimeter of a rectangle can be found by doing 2 times the length plus 2 times the width. The perimeter is the distance, remember, around a figure. So you can double the length, double the width, and then add those two amounts together. And then the question or the problem is asking you to find the dimensions of the garden, meaning find what the actual length and actual width are. So go ahead and check over your answer for that one. Okay, great. Again, if you have questions about any of these problems, remember, see me. I'm happy to help. Go ahead and turn this in, and you're ready for your independent practice. Good luck.